Our Earth is incredibly old. It has witnessed countless changes and transformations over billions of years. Imagine a clock that shows all of Earth's history. This clock would span billions of years, each tick representing monumental shifts in the planet's development. If we were to set midnight as the time Earth formed, humans wouldn't appear until a few seconds before the next midnight. This perspective highlights just how recent our presence is in the grand timeline of our planet. To understand how life arose on our planet, we must journey back to the beginning, to an Earth vastly different from the one we know today. This journey takes us to a time when the planet was young and raw. Let's rewind the clock about 4 billion years to uncover the secrets of Earth's ancient past. This era holds the key to understanding the origins of life and the formation of our world. This journey takes us back to a time when Earth was a newborn planet, still forming from the leftover dust and gas of our sun's birth. The solar system was a chaotic place, with planets and moons taking shape. It was a time of intense heat, volcanic eruptions, and constant bombardment from asteroids and comets. These violent events played a crucial role in shaping the early Earth. This early Earth was a hostile and alien world, far from the life-sustaining planet we call home today. The atmosphere was toxic, and the surface was a molten landscape, yet these harsh conditions set the stage for the emergence of life.
Imagine a world covered in fiery volcanoes, spewing molten lava across the surface. The ground is a seething mass of red-hot liquid rock, constantly shifting and reshaping the landscape. The air is thick with noxious gases, making it nearly impossible to breathe. The sky glows an angry red, casting an eerie light over the tumultuous terrain. This was Earth's early environment, a landscape shaped by intense volcanic activity. Massive eruptions were a common sight, with lava fountains reaching high into the sky. It was a time before oceans and continents as we know them, a time when Earth's surface was still solidifying from its molten state. The planet was a vast, barren expanse, devoid of any recognizable features. Adding to the chaos were frequent impacts from asteroids and comets, remnants from the formation of our solar system. These celestial bodies bombarded the planet, leaving craters and scars on its surface. These impacts, some larger than entire continents, released tremendous amounts of energy, vaporizing any existing water and further heating the young planet. The collisions were so powerful that they could alter the planet's rotation and tilt. It's hard to imagine life surviving in such extreme conditions, but this was the cradle in which our planet's story began. Despite the hostility, these extreme conditions set the stage for the complex processes that would eventually lead to the emergence of life.
Despite the intense heat, a remarkable transformation was taking place. As Earth cooled, water vapor trapped in the atmosphere began to condense. Torrential rains, unlike anything we see today, lashed the planet's surface for millions of years. These rains formed shallow oceans, covering much of the young Earth in a vast primordial sea. The oceans were not the clear blue we know today. They were likely a murky green, filled with dissolved minerals and gases from the atmosphere. These early oceans, though toxic by today's standards, held the key ingredients for the emergence of life.
The origins of life are still shrouded in mystery, but scientists believe that life arose in these early oceans. Imagine simple, single-celled organisms, far simpler than even the most basic bacteria we know today. These early life forms thrived in the harsh conditions, drawing energy from the chemicals dissolved in the ocean water. One leading theory suggests that life may have originated near hydrothermal vents, underwater volcanoes that spew hot, mineral-rich water into the ocean. These vents provide a source of energy and chemicals that could have supported the first life forms. Regardless of where exactly life began, it is astonishing to think that these simple organisms would eventually give rise to all life on Earth, from bacteria to dinosaurs to humans.
While life was gaining a foothold on Earth, a dramatic event unfolded in the solar system. Known as the Late Heavy Bombardment, this period saw a significant increase in asteroid and comet impacts on the inner planets, including Earth. Imagine a cosmic storm, with asteroids raining down on our planet for millions of years. While seemingly destructive, this bombardment may have actually helped life flourish. The impacts delivered water and organic molecules to Earth, providing the building blocks for life. Additionally, the constant upheaval created new environments and opportunities for life to adapt and evolve.
Early life forms, called prokaryotes, existed without oxygen. In fact, oxygen was toxic to them. However, around 2.4 billion years ago, a new type of organism emerged: cyanobacteria. These tiny organisms possessed a remarkable ability. They could perform photosynthesis, using sunlight to convert water and carbon dioxide into energy and releasing oxygen as a byproduct. This oxygen production had a profound impact on Earth's atmosphere. Over millions of years, oxygen levels rose, fundamentally changing the planet's chemistry. This oxygen revolution was a pivotal event in Earth's history, paving the way for the evolution of oxygen-breathing life forms, including ourselves.
Section 7. The Rise of Continents. Meanwhile, Earth's surface was also undergoing dramatic changes. Volcanic activity continued to shape the landscape, and tectonic plates shifted, pushing and pulling at the Earth's crust. Over time, these processes led to the formation of continents, land masses that rose above the vast oceans. The emergence of continents had a significant impact on life. It created new habitats and allowed life to spread and diversify. The interactions between land, sea, and atmosphere became more complex, setting the stage for the evolution of even more diverse ecosystems.
Section 8. Early life explodes. With the rise of oxygen and the formation of continents, life on Earth exploded in diversity. Simple single-celled organisms gave way to more complex life forms, including multicellular organisms. The first plants and animals evolved in the oceans, eventually colonizing the land. This period, known as the Precambrian Era, saw the emergence of many major groups of organisms that would go on to shape life on Earth, from sponges and jellyfish to worms and early arthropods. It was a time of incredible experimentation and innovation as life explored new ecological niches and evolved into countless forms.
Section 9. A time capsule of our past. Looking back at Earth's early history is like peering into a time capsule. By studying rocks, fossils, and the chemical signatures of ancient life, scientists can piece together the story of our planet's past. These clues reveal a dynamic and ever-changing Earth, shaped by forces both destructive and creative. Understanding Earth's past is not just about satisfying our curiosity. It provides us with a framework for understanding the present and future of our planet. By studying how life adapted to past environmental changes, we can gain insights into how life might respond to the challenges facing us today, such as climate change and habitat loss.
Section 10. Echoes of the Beginning. As we conclude our journey back to Earth's early history, we are left with a sense of awe and wonder. The vast expanse of time that has passed since our planet's formation is almost unimaginable, yet it has shaped the world in ways we are only beginning to understand. From a fiery, chaotic beginning, life emerged and flourished, transforming our planet into the vibrant and diverse world we know today. The relentless volcanic activity and the molten lava flows created the conditions necessary for life to take hold and evolve. The story of Earth's early years reminds us that we are part of something much larger than ourselves, a continuous narrative of change and evolution that spans billions of years. Each fossil, each rock layer, tells a chapter of this grand story, connecting us to the ancient past. By understanding our planet's past, we can better appreciate the fragility of life and the importance of protecting our pale blue dot, the only home we know. The delicate balance of ecosystems and the intricate web of life are a testament to the resilience and vulnerability of our world. As we continue to explore the universe, we carry with us the legacy of those early life forms that endured unimaginable challenges to pave the way for our existence. Their survival against the odds is a powerful reminder of the tenacity of life. Their story is our story, a testament to the resilience and interconnectedness of all life on Earth. Every living organism, from the smallest microbe to the largest mammal, is part of this intricate tapestry woven together through time and space.